Welcome to day 6. This is going to be the first day on linear programming, and what I'm going to do in this lesson is, to start, I am going to give an example of what we are eventually building up to. And the reason I want you to understand, put the whole picture together, and then what we're going to do on the next couple of examples is break it down for you. Okay? So we're going to be talking about word problems, and we're going to be dealing with the idea of maximizing or minimizing, costs and budgets and, amount of things that we want to sell or buy. Okay, so in this first example, your class plans to raise money by selling t-shirts and caps. The plan is to buy the t-shirts for $8 and sell them for $12, and buy caps for $4 and sell them for $7. The planning committee estimates that you will not sell more than 120 items. Alright, big reminder, when they say things like that you will not sell more than 120 items, okay, that's a hint as to one of the constraints that we're going to have. Your class can afford to spend as much as $800 to buy the articles. Okay, our objective here is going to be to try and maximize our fundraising capabilities. So to start, to define our variables, x is going to equal the number of shirts, and y is going to equal the number of caps. Alright, constraints. The first one, you will not sell more than 120 items, means that the number of caps plus the number of shirts has to be less than or equal to 120 pieces. Okay. Next, you cannot afford to spend as much as $800. So just remember that your t-shirts cost $8, so that would be 8x. Your caps cost $4, so that's 4y. And it has to be less than or equal to $800. Again, like we did in the last example in the video, you need to have x is greater than or equal to 0. You can't have a negative amount of t-shirts, and y is greater than or equal to 0. Alright, notice that we have not used the 12 and the 7. That will come up later when we talk about our objective function. Now, the overall goal is we want to graph these inequalities, okay, and then we're going to find the points of intersection, the vertices. And the vertices are going to be where our maximums and our minimums are going to occur. Okay, so keep that in mind. The vertices are the most important pieces. Alright, so let's go ahead and take a look at our graph here. Okay. Alright, so when I graph this, okay, reminder to start, I'm going to do my first inequality of x plus y is less than or equal to 120. I'm going to make my t-chart, and basically if x is 0, y is 120. If y is 0, x is 120. When I go to do my 8x plus 4y is less than or equal to 800 and make my t-chart, if x is 0, y is 200, and if y is 0, then x is 100. So notice that I have to go up to 120 on the x-axis, and I have to go up to 200 on the y-axis. The graph here has 20 boxes, so we could basically go, each box is 20. So I'm going to go ahead and scale that, and then we will graph our inequalities. Alright, now that I have it scaled, I can graph it. I'll start with my x plus y is less than or equal to 120. So I'm going to start at my y-intercept of 120. I have my x-intercept of 120. That means my slope is 1, negative 1 over 1. So I'm going to basically go from corner to corner, and I create this inequality. Okay, since I want less than it, or if I were to test the origin, 0 plus 0 is less than or equal to 120. I'm going to shade towards the origin or less than the line. When I go to graph the second one, I have an x-intercept occurring at 100, a y-intercept occurring at 200. I'm going down 200 over 100, which means it's down 2 over 1. So I have the following points that I can look at. Okay, and it looks like they're going to intersect right there. So I got to keep that in mind. Okay, and then of course I've got, x is greater than or equal to 0 and y is greater than or equal to 0. Okay, and so that means I am going to be shading this region right here. Okay, now the important pieces are the vertices of the shaded region. So this 80, 40 is an important point. This 100, 0 is an important point. 0, 0 is an important point. And the last one up here of 0, 0, 120 is an important point. So we're mainly only concerned with the vertices of this shaded region, which we were able to find. Okay, so we got to keep those points in mind as we move forward. All right, I'm going to go ahead and flip to the following page. All right, so we did label our vertices on our graph. Okay, so that's done. Those were 0, 0. We had 100, 0. We had 80, 40, and then we had 0, 120. So let's keep that in mind. Now our club wants to maximize the profit that it makes from the fundraiser. So our goal is to write a profit function. We're going to use P in order to do that in terms of our defined variables of number of t-shirts and caps. So P is going to equal, and here's the tricky part that you got to keep in mind, is we're buying our t-shirts for $8 and selling them for $12, so we actually make $4 per shirt, and then we're buying the baseball caps for $4 and selling them for $7, so $3 per cap. So that's our profit, or eventually we're going to call that our objective function. The objective of this is to find our maximum profit. So at which point do you maximize your profit? Well, what we do is we take the vertices, which we have up here, and we plug them all into this and figure out which one comes up with the biggest p-value. So if I start with the simplest one, 0, 0, well, p would equal 4 times 0 plus 3 times 0, and naturally if you don't sell any baseball caps or t-shirts, your profit is going to be $0. Now we could do all t-shirts and no caps, and if we did that, 4 times 100 plus 3 times no caps would equal $400. On the flip side of that, we could do no t-shirts and just do 120 baseball caps, and 4 times $0 plus 3 times 120 would equal $360 in profit. And then the last one, the 80-40, we could have a profit of 4 times 80 plus 3 times 40, and this yields a 320. This yields a 120. Add that together, and that gives us our greatest profit of $440. Okay, so the goal would be for us to sell 80 t-shirts and 40 baseball caps to maximize our profit and get $440. Alright, so that is, the overall objective of what we're going to do. Okay, so that's one big piece. You're going to have to, in quick review, come up with inequalities, define your variables, graph, come up with an objective function. This is our objective function. and then from there, find the vertices and figure out which vertice maximizes the profit or minimizes our cost. Alright, let's go ahead and move on to the next example. Okay, so now, just breaking it down for us, okay, you are given a graph of the constraint inequality. So it's already graphed for you. You're supposed to find the maximum and minimum values of the objective quantity. So this P equal to is our objective function. So it's already done. It's already graphed for us. The vertices are all done. So all we have to do is plug each of these points in for x and y and figure out which one gives us the max and which one gives us the min. So I'll just go in a clockwise direction. So if I had 0, 0, P would equal 0 minus 0 or 0. If I had 0, 6, P would equal 0 minus 6 or negative 6. If I had 2, 7, P would equal 2 minus 7 or negative 5. And if I had 5, 0, P would equal 5 minus 0 or 5. So our max is 5. Okay, the max is 5. The 0.50 gives it to us. And our min is negative 6. And the 0.06 gives it to us. Okay, so that's just breaking it down for us so we understand the idea. Alright, last example. Alright, now what we have is, instead of it being a word problem, we want to graph the constraints, or the inequalities that are presented, find the vertices, and then find the max and min using our objective function, just like we did in the last example. So, x is greater than or equal to 0 is this, and greater than or equal to 0 means I'm going to go this direction. Y is greater than or equal to 0 is the x-axis. I'm going to go above it. And then 2x plus y, I can either change this into slope-intercept form by subtracting the 2x over. Some of you like to do that. So 2, 4, 6. Negative 2 means down 2 over 1, down 2 over 1, down 2 over 1. I come up with the following line. Okay, if I test the origin with this one, I would get 0 is less than 6, which is true, so I am going to shade this little triangle right here. And again, the important pieces are our vertices. So we have a vertex here at 0, 0. We have one occurring up here at 0, 6, and then one occurring here at 4, 0. So I'm going to plug each of those into my objective function. So 0, 0, P would equal 3 times 0 minus 0 or 0. 0, 6, P would equal 3 times 0 minus 6 or negative 6. And then 4, 0 gives me a P of 3 times 4 minus 0 or 12. So my minimum is negative 6 and 12 is my max. Okay, and that is linear programming, and those are the basics of it, and we'll expand on that in the next video. Again, as always, bring questions to class if you have them.